What if we told you that the answers to the solar system's greatest mysteries aren't in distant galaxies, but drifting silently between Mars and Jupiter? These aren't just space rocks, they're time capsules, ancient messengers that have witnessed the birth of planets, the fury of collisions, and the fading light of forgotten worlds. And now, for the first time in human history, we've begun to reach out and bring those messengers home. Welcome to the new era of asteroid exploration. It all started with a question. What are asteroids really made of? Are they just dead debris? Or are they relics of a world that could have been? To answer that, we needed more than telescopes. We needed to go there. And so, missions like NASA's OSIRIS-REx, JAXA's Hayabusa and Hayabusa 2, and NASA's Dawn spacecraft were born. Their goal? To visit asteroids, touch them, sample them, and return with pieces of the early solar system locked in stone. Let's begin with OSIRIS-REx, one of the most ambitious missions in NASA's history. Launched in 2016, this spacecraft traveled over 200 million miles to reach Bennu, a near-Earth asteroid roughly 500 meters wide. But Bennu is no ordinary rock. It's ancient, older than Earth itself, formed in the first 10 million years of the solar system. What made Bennu particularly fascinating is that it's rich in carbonaceous material, the building blocks of life. Scientists hoped that by studying samples from Bennu, we might better understand how organic molecules arrived on Earth. In October 2020, OSIRIS-REx made history when it extended its robotic arm and performed a flawless touch-and-go maneuver, scooping up dust and rock from Bennu's surface. That sample is now en route to Earth, scheduled to arrive in a secure capsule. What secrets lie within it? No one knows. But whatever they are, they could redefine our understanding of how life began. Across the Pacific, the Japanese Aerospace Exploration Agency, JAXA, was running its own groundbreaking missions. In 2005, Hayabusa became the first spacecraft to land on an asteroid and return a sample to Earth. It visited Itokawa, a peanut-shaped asteroid made mostly of silicate rock, and though the mission faced technical setbacks, it succeeded in returning dust particles, enough to prove that direct sampling was possible. Then came Hayabusa 2, targeting the asteroid Ryugu, a larger, darker, and more primitive body. Launched in 2014, the mission arrived at Ryugu in 2018 and did something extraordinary. It fired a bullet into the asteroid's surface, collected samples, and even dropped a small impactor to blow a crater in the surface, exposing material untouched by radiation or micrometeorites for billions of years. The samples returned to Earth in 2020 and are now being analyzed. Early results have shown evidence of water-bearing minerals, further supporting the idea that asteroids may have delivered water and life's ingredients to early Earth. But the story doesn't stop there. NASA's Dawn mission took a different approach. Instead of returning samples, Dawn became the first spacecraft to orbit two extraterrestrial bodies, Vesta and Ceres, the largest members of the asteroid belt. At Vesta, Dawn captured images of massive impact craters, canyons, and mysterious grooves that circled the asteroid's equator. It revealed that Vesta is differentiated, meaning it once had a molten core, just like Earth. That suggests Vesta nearly became a full-fledged planet, but was stopped short, likely by Jupiter's gravitational interference. Then Dawn traveled to Ceres, where it discovered bright spots inside craters. These turned out to be salt deposits, hinting at briny water beneath the surface. Ceres, it turns out, might be geologically active even today, another candidate for harboring microbial life in underground oceans. What all these missions reveal is that asteroids are not just relics of destruction. They are repositories of creation. They tell a story far older than humanity, a story written in dust and rock, a story of heat and pressure, of impacts and chemistry, of time so deep we can scarcely grasp it. And perhaps most importantly, these missions are helping us answer one of the most profound questions of all. How did life begin? If carbon-rich asteroids like Bennu contain amino acids, or precursors to RNA, it supports the theory that life didn't start on Earth. It arrived here, seeded by cosmic messengers from deep space. This theory, known as panspermia, is no longer science fiction. It's being tested in laboratories right now using real samples from real asteroids. Think about that. We are touching the origins of life. But asteroid missions aren't just about the past. They're also about the future. Asteroids may one day become resource hubs, supplying rare metals, water, and even fuel for deep space missions. Mining asteroids could reduce the need for costly launches from Earth and allow long-term survival in space. Companies like Planetary Resources and Asteroid Mining Corporation are already researching how to harvest materials from near-Earth asteroids. Some even dream of building habitats inside hollowed-out asteroids, shielding colonists from cosmic radiation while orbiting the Sun like drifting space cities. It's bold, it's visionary, but it's not impossible. Just as our ancestors once crossed oceans to find new lands, we may soon cross the void of space to claim the stars, and the stepping stones on that journey are asteroids. As of now, only a handful of missions have touched them. But each mission returns with gifts from the ancient past and visions of a future where humanity thrives among the stars. So next time you look up and see a shooting star, remember, it might just be a piece of a lost world, or the first whisper of a future one. In the next episode of Infinity Beyond, we'll explore the weirdest and most terrifying asteroids ever discovered. Ones that spin at deadly speeds, hide in Earth's shadow, or are made almost entirely of precious metals. If you're loving this journey through space and time, hit that subscribe button and help us uncover the secrets of the universe, one cosmic stone at a time.